Get ready for a journey beyond the stars. Here on Interstellar Voyage, we explore the mysteries of the universe and travel to worlds you've never imagined. Like and subscribe so you don't miss a thing. In 1915, a wild-haired German physicist proposed something that seemed impossible. Albert Einstein claimed that space and time could bend like rubber, that gravity wasn't a force pulling objects together, but a geometric deformation of reality itself. His equations suggested that massive objects literally warped the universe around them. For over a century, this radical idea remained one of science's most audacious and untested claims. But in 2019, a revolutionary discovery in galaxy M87 finally confirmed the unthinkable, providing humanity with the first visual proof of Einstein's most mind-bending prediction. To understand this earth-shattering discovery, we must journey back into Einstein's revolutionary mind. He wasn't simply adjusting existing physics, he was rewriting the fundamental laws of our universe. His general theory of relativity suggested that massive objects don't just exist in space, they actively sculpt it, creating invisible wells. In the four-dimensional fabric called space-time, imagine space-time as a stretched rubber sheet. Place a bowling ball in the center and it creates a depression. Roll marbles nearby and they follow curved paths around it. This, Einstein claimed, is gravity, not a force but geometry itself. But how do you prove something so abstract? How do you photograph the curvature of reality? The answer was hidden in a distant galaxy, 55 million light-years away, waiting for humanity to develop the technology to witness it. Messier 87, known as M87, is a supergiant elliptical galaxy in the constellation Virgo. This cosmic metropolis contains over 1 trillion stars, 100 times more than our Milky Way. But at its center lurks something extraordinary, a supermassive black hole, 6.5 billion times more massive than our Sun. To grasp this scale, if our entire solar system were a coin, this black hole would span a football stadium. Its event horizon stretches 120 times the Sun-Pluto distance. For decades, astronomers knew something apocalyptic was happening at M87's core. Colossal jets of superheated plasma erupted at 99% light speed, stretching thousands of light-years. But the engine driving this violence, the black hole itself, remained invisible, hidden behind its own overwhelming gravity. In 2017, over 300 scientists in the Event Horizon Telescope collaboration decided to attempt the scientifically impossible, photograph a black hole. Their target was M87's supermassive monster, chosen for its enormous size and dramatic activity. The challenge was absurd. A black hole doesn't emit light. It devours everything, including photons themselves. So how do you photograph something fundamentally invisible? Einstein's equations provided the answer. A black hole would create a distinctive circular shadow, a region where no light could escape, surrounded by a brilliant ring of material heated to billions of degrees as it spirals toward oblivion. To capture this cosmic fingerprint, scientists needed a telescope with resolution so extraordinary it could read a coin's date on the moon. They needed a telescope the size of Earth itself. 8 of the world's most powerful radio telescopes, from Chilean deserts to Hawaiian volcanoes, from Spanish mountains to Antarctic ice, were synchronized with atomic precision to function as one Earth-sized instrument. This network achieved resolution sharp enough to read a New York newspaper from London. The technical challenges were staggering. Each telescope had to point at the same sky patch simultaneously, accounting for Earth's rotation and atmospheric disturbances. Timing had to be perfect to billionths of a second. For 5 nights in April 2017, these sentinels collected 5 petabytes of data, equivalent to thousands of computers worth of information, but transforming this data mountain into a single image would require 2 years of intensive computational processing. April 10th, 2019. A date forever etched in human discovery. The scientific world held its breath as Event Horizon Telescope representatives prepared coordinated press conferences in 6 cities: Washington, Brussels, Santiago, Shanghai, Taipei, and Tokyo. At precisely the same moment, the same image appeared. On screens worldwide, a brilliant golden ring surrounding a perfectly circular void of absolute darkness. The silence was deafening. There it was, exactly as Einstein had predicted 104 years earlier. A black hole's shadow, its event horizon clearly defined, surrounded by material heated to billions of degrees. The shadow measured 40 billion kilometers across, 3 times Pluto's orbit. The ring's asymmetric brightness revealed something remarkable. This cosmic giant was spinning, dragging space-time itself around with it. Humanity had achieved the unprecedented. We had photographed the unseeable and turned Einstein's abstract mathematics into visual reality. This wasn't just a pretty picture, it was definitive confirmation of one of Einstein's most audacious predictions. The curvature of space-time was there, visible, undeniable, but M87 revealed even more secrets. The asymmetry in the ring's brightness confirmed that the black hole was rotating, dragging space-time itself along with it. The polarization of light revealed extremely organized magnetic fields, finally explaining how the relativistic jets were formed. The implications of this discovery echoed throughout modern physics. It confirmed not just the existence of black holes, but validated our most fundamental understanding of gravity, space, and time. Universities around the world celebrated. The Nobel Prize in Physics was reconfigured. Physics textbooks needed updating. A new era of astronomy had begun, the era of black hole astronomy. Einstein never lived to see his most radical theory confirmed so spectacularly. He died in 1955, decades before the first computers capable of processing the calculations necessary for this discovery. But his genius transcended time. With just paper, pen, and an extraordinary mind, he unraveled secrets of the universe that we could only confirm with the most advanced technology of the 21st century. M87 was just the beginning. The Event Horizon Telescope has already captured images of the black hole at the center of our own galaxy, Sagittarius A*. Future space telescopes promise even more detailed images, perhaps even videos of material falling into black holes. Each new observation confirms more of Einstein's predictions, revealing a universe even stranger and more beautiful than we ever imagined. So was Einstein right? The answer resonates across 55 million light-years of distance in the form of a brilliant golden ring surrounding absolute darkness. Yes, Einstein was right, and M87 confirmed the unthinkable, that our reality is far more extraordinary than our senses can perceive. The universe is not just strange, it's stranger than we can imagine, dedicated to the memory of Albert Einstein and all scientists who dared to question the impossible.